Hello, folks. Welcome to Rational Science, the only site on the internet that does physics rationally. And probably wasted your time coming here today because I'm going to be talking about nothing. Now, how long can that take? 0 seconds? Anyways, we're going to be answering some questions at the end of the show, but we begin again, as always, with our extinction segment. What is that all about? Well, we suggest here, we theorize, we argue here that we are the last generations of humans on Earth. I don't know how long it'll last, maybe another 10, 20, 30 years at most. I have no idea. I can't tell you exactly when. I'm saying we're very close to the end and that there is nothing that we can do about it. Zero D, nothing. Okay? Um, what's going to happen? What's going to cause our extinction? A comet's going to hit us? Climate change? No, it's the global economy. Global economy will, not may, but will collapse. There is nothing we can do about it. It's guaranteed, just like it's guaranteed that humans will not overpopulate the earth. You know, we're probably going to have another billion more people by the time extinction comes around. Maybe we'll reach, right? About 9 billion people on the planet, and that's going to be it. And that's going to be part of the reason that we stop our economic growth as well. Aside from the fact that there is a qualitative thing going on as well, which is, for 200,000 years, maybe 300,000 years since the beginning of our species, we were, for the most part, hunter-gatherers, maybe 95% of that time. About 10, 15,000 years ago, we went into agriculture, farming. About 200 to 300 years ago, we went into manufacturing industry. And about maybe 30, 40, 50 years ago, we went into services. And there's almost no hunter-gathering today. I don't think there's any real hunter-gathering. Even the pygmies in the jungles have a cell phone today. So there's no real hunter-gathering. Farming is being done by corporations for the most part, or getting there. Eventually, if we keep on the path we're on today, it's all going to be done by corporations, big corporations, agricultural corporations. And the workers will have no other choice but to be working in either manufacturing or services. But manufacturing is dying, okay, because we're producing this more efficiently as time goes by. We try to be more efficient. Companies compete against each other, and so they put more efficient processes on the line. And that is going to push everybody into services. And services is another word for unemployment. Person who works in services is doing unemployment. He's not really working. He's not in direct contact with nature, with food. And food is all we need to live, to stay one more day alive. So here we have a situation where you have people who are working in things, in activities that are not producing food. See, in the old days, we produced food directly. The guy went there with a spear and killed an animal and lived one more day. And we're not there today anymore. Today we depend on someone else to produce the food for us. And all we're doing is passing money around, giving it to the person who produces food so that he feeds us. And when that cycle is interrupted, that's the end of all of us. And that's what I think will happen when the global economy collapses. Global, okay? Anyways, so we look at things related to extinction, some signs out there, some trends, and how they're related to extinction, okay? And here's one trend that's happening these days. It's that people are working from home. And there's one fellow says, 50-year-old NYU professor went viral for telling young folks that they need to be out of the house for success. But his advice got blasted. By 2025, 36 million Americans may be clocking in from the comfort of their home. Okay, so people are moving into this mode in which they work from home. But then I looked it up, and here's this McKinsey report, and it says The most striking figure to emerge from this research is 58%. That's the number of Americans who reported having the opportunity to what? Work from home at least one day a week. 35% of respondents report having an option to work from home 5 days a week, etc., etc. Point is, the people want to work from home, and the problem I had with this little report was it says over there, it says in every part of the country and sector of the economy, including traditionally labeled blue collar jobs. I had a problem with that. And I'll tell you why. Because I'm saying that you cannot work from home from true, genuine blue collar jobs, manufacturing jobs, industry jobs. Here's from that same article, it gives you a listing of the jobs that people are working from home lately, okay, or at least getting into that mode in which they work from home, okay. Give me a second here. Went on the other side. There we go. And if you look at these jobs, the occupations, and I'm just going to put a couple examples here. Look at the bottom, fifth from the bottom, it says farming, fishing, and forestry. I'm not sure you can do a lot of farming from your house, on your carpet, apartment carpet, Fishing, I don't know what you can fish there. So obviously, these so-called manufacturing or industry-related jobs, they're talking about within that industry, people who work with computers. Okay, so what's increasing are the computer jobs. Okay, internet stuff, and not really blue collar work. I'm not sure what blue collar works they're referring to. They didn't go into that kind of detail. They just mentioned that blue collar jobs were increasing. I'm saying that's not the case. What's increasing are services. In other words, computer work, internet stuff, maybe phone, that kind of stuff. So here's the trend I've been showing for some time. Here it is one more time. Okay, you can see that we've been hunter-gatherers for most of our existence. About 10,000, maybe 15,000 years ago, we went to agriculture and farming. Manufacturing 2 to maybe 300 years ago, and about maybe 30, 40. This is an old chart, by the way. I haven't updated it, but the important thing is the trends. And you can see that maybe 30, 40 years ago, maybe even 50 years ago, we started getting more into services. And about 10 or 15 years ago, we went into a special type of service, a service within service, an industry within an industry, or a category within a category. And that is that we've gone into internet services. And that's what's increasing today. Everybody's getting into some kind of internet type of job, and abandoning, hands-on type of services like landscaping, barbering, that kind of stuff. That's falling behind. A lot of stuff is going to be taken over by chat GPTs, and so they're probably going to take a lot of jobs in the future, and that's going to squeeze the proletariat, the person who depends on a salary, out of the job market. What are these people going to do? Well, they're going to depend on government help, and government's going to have to send them a check. And who pays for that? Well, the people who work. They take out of their paychecks and give to the people who don't work. That's the way it works today. And obviously, the more people are in the unemployment or welfare line, the fewer people that are working. You can see that that trend cannot be continued. And I think that's part of the process that's going to cause the collapse of the global economy. Okay, but there is another trend on top of that, and that is that even even these technology jobs, as they're called, internet jobs, they're disappearing as well. They're kicking people out of those jobs. And here's a report that came out, a little bit of news, says Google last week announced it would lay off 12,000 people from its staff. And it's the latest big tech company. They mentioned a couple others, right? Microsoft and Amazon, Meta, etc. Says to enact mass workforce reductions in recent months. And they go over this. They say there have been more than 200,000 tech jobs lost since the start of last year. Okay, so just keep that in mind. Maybe these companies which provide a lot of the work out there, by the way. Okay, not only direct work, but also secondary work. You know, companies that service them or subcontract, etc. Um, you know, you don't want these big corporations to come down. And again, if you introduce into these big tech corporations things that, you know, robots, I call them robots, that do the job that humans should be doing, that's even going to squeeze more people out of the market, out of the job market. So I think that's a trend that you have to be watching, you know, maybe not panicking, but certainly watching. Okay. Another trend that seems to be happening, I don't know if this is true, I mentioned this the other day, and that's the UFOs. And it says 1 in 5 professors say they had a UFO, right, encounter. Okay? And so you see some of this in the news lately. I don't know if this is a new trend. Okay, here's another piece of news. Body cam recording catches cops investigating potential UFO crash. And they immediately put these weird extraterrestrials as a picture, you know, to catch your attention. And the question is whether there's a trend now to, you know, distract people from other issues, and maybe that's why this is going on. I don't know if this is real or it's just a fad again that's beginning. So I looked at the trend. I'm saying, are there more sightings, or is this on the up and up? And this is what I found. I said reported UFO sightings by month, and then you have their by year, and you can see they're coming down. Fewer people are into it, so maybe I'm wrong. Maybe there is no upward trend. The only upward trend is the people who see, you know, unidentified flying objects that look like Saturn. You know, the classical disk. Okay, people see more of those out of those people who do see UFOs, unidentified flying objects. So, is there a trend to distract people from other issues, maybe the economy? And so they put these things there, or is there a real fad going on? This is coming back into being, you know, in the news. My take on this, we can't leave the earth, we cannot save ourselves, and neither could any other civilization that ever existed or exists out there today. In other words, if there are Klingons out there somewhere on a planet, which is very, very likely, okay, I think it's almost impossible that there isn't, okay, some other civilization out there. But for them to contact us or be here, having come down here, that's impossible. That's simply impossible under the rope model. Okay, here's why. I'm going to illustrate it for you. Okay, here's us trying to escape the Earth. We have our little rocket. Okay, and we're going to try to leave the Earth and go to, I don't know, the nearest star. Okay, that's assuming we're going to assume that everything is nice and peachy over there. You know, pristine. Garden of Eden is waiting for us, so we just go there and inhabit, and everything's already done for us, okay? And so let's just assume all that. And here's what would happen, okay? Here's you trying to leave the Earth, okay? Every atom in your rocket is, including yourself, is bound to every atom on Earth. In other words, there's a connection there from every atom to every atom, okay? So as you try to leave the Earth, okay, it's not that you're stretching anything, okay? So don't get the wrong idea. What you're doing is sliding through existing ropes that connect the Earth, for example, to Alpha Centauri, okay? So you're going to go to this nearest star. You're going to go through these existing ropes, okay, that attach every atom in your body and every atom in your rocket to every atom on Earth and to every atom in Alpha Centauri, okay? We're just going to use this system. And what I'm saying is, the farther away you get from Earth, okay, the more you get into what I call the linear region, the linear regime. Okay, and here it is. Here's a view of that. Here you have the Earth, the Sun, and the bird's beak, and that long region there between the two stars is the linear regime. Okay, Proxima Centauri on one side, the Sun on the other. As you try to leave the solar system, you enter this region where the ropes are almost as one, as a, you know, they come together like a coaxial. and it's a region that has no gravity, no Newtonian gravity. Newtonian gravity only occurs in the Birdspeak region. So once you get into the linear regime, you don't have anything pulling on you. Okay, and what happens is like you hit more or less a region where you slow down and you have all these ropes just you're sliding through all these ropes all the way to Alpha Centauri without any pull, without any tug. There's no gravitational pull on you, okay, from either star when you get into the linear regime. So, so if this is the case, we're going to make that assumption, then it's impossible for any living entity to travel from star to star interstellarly. That's our view here, okay, just so you know. And so it's important to know whether the rope model has any validity whatsoever, if that's what's out there. Okay. Okay, another issue related to extinction. Here we have Saudi Arabia looks to China for business as U.S. influence wanes. And yeah, what's happening is that Saudi Arabia, also the United Arab Emirates the other day, they're all kind of ditching the United States a little bit. They're trying to maintain an even-handed position, what used to be called the third world, okay, equidistant from Russia and China on the one hand and from the United States on the other. And this is a significant change because the United States had a lot of influence over the Middle East, and I think that is dying a little bit. These countries are not willing to follow the United States anymore. They have a little bit of power now. The other day, the Saudi Arabia and Iran reached an agreement after so many years where they were enemies. They have ambassadors in each other's capitals. And they also allowed Syria, which was banned, back into the Arab Union. And so it's happening. And it doesn't favor the U.S. interest in that region of the world. And China, meanwhile, is buying a lot of oil from countries like Saudi Arabia and others. And so, they're starting to have more business with China than with the U.S. And since China can sell them some technology that's being produced by their manufacturing processes, it's leaving the United States and Europe a little bit out of the deals. So that's another trend that's going on, so keep that one in mind. Okay, so the other day we talked about some other issue that's going on, and that's all this trans issue. A lot of people changing their sex. Quite scary. Can you imagine, cutting that thing there? Oh my God, I can't even imagine that. But in the old days, I had three sons, and I would tell them little bedtime stories before they go to bed. And I would tell them stories like from Aesop's Fables and Hans Christian Andersen, things of that nature. But I also pulled stories out of the Bible, okay? And no, I did not pull stories like this one, where Potiphar's wife pleads with Joseph to sleep with her. Even though, the girl looks pretty good, so I don't know why he would reject her. I think that's more of a fairy tale, okay, if you ask me. But I mean, unless that's not what the girl looked like, maybe she was fat and ugly and had hair all over, I don't know. But no, I would tell him stories like of this caliber, Joseph being sold to Egyptians or to a caravan as a slave. He ends up in Egypt. He becomes a very important man, and then one of his prophecies comes true, and that is that his brothers and his father will one day bow down to him, and that's exactly what happens according to the Bible. Uh, did it happen? I don't know if it did. I think it's a great bedtime stories, and you'll find lots of them in the Bible. Bible is one of my favorite books, and I'm not kidding you there. It's a good book. I read it 3 times completely from beginning to end, when I was young. And I recommend it to anyone. It's an interesting book, not so much because what it says is truth. It's to me, it's very interesting because it gives you an idea how people were thinking in those days, what was important to them. Okay, it gives you a lot of insight into that. So There's a lot of stuff I like about the Bible. Old Testament, the New Testament, I don't care about. But the Old Testament, I think, is a pretty interesting historical book. The only part of the New Testament is how religion changed. If you look at the Old Testament compared it against the New Testament, yeah, religion did change. This God, this manly God, with 2 feet and a head and 2 arms, etc., he turns into this abstract concept. Okay, now he becomes love, he becomes intelligence, and so on. So God became an abstraction. Okay, so when you pray today, well, you're praying to an abstraction, not to the God who had a magic wand, waved it, and made the universe. That God is gone. Okay? Not too many people believe in that God today. Even I'm talking about religious people, people who Christians and so on. Okay. So what are the bedtime stories of today? Well, they're a little bit shocking. So right now, if you don't want to be shocked, turn your screen off, okay, for a few seconds. I'll give you 3 seconds. 1, 2, 3. These are the books that you see today. Okay, these are the bedtime stories. In My Daddy's Belly. So we have the two daddies, okay, and one of them has a baby in his tummy. Okay, so these are the bedtime stories of today. A little bit shocking. And yeah, you wouldn't have even imagined this in the 1960s or 70s. Believe me, this is completely out of anybody's guess in those days. Part of the reasons for this, you have people like the government, they're somehow spreading this from a propagandistic point of view. They're heavy on equality, and so this is something they're pushing. And then I think they will win eventually because people will put equality above anything else. And so, what can I tell you? The laws are going to change. There's like 500 or 600 laws right now being discussed in the United States to help these folks and or hinder, because there are people on both sides of the issues, obviously. And so the question is, who's going to win? My bet is that the people who are going to win are the people who vote for equality. Anything related to equality, I think, eventually is going to triumph. It's going to be victorious, successful. And that's simply the way it is, because they put that above anything else. And they forget about, all the other stuff, what these people do in bed, and they don't care about all that. They say equality. We should treat everybody at the same level. And I think that's going to win in the end. Okay, so for the new generation, these are the type of women you'll find in the future. Okay, this is what they look like. Some have transition. Fellow on the far right over there, he's the fellow who's been criticizing my theory. I found out a short time ago that he's transitioning, okay, turning into something. I did not know about the sign that's behind him. I didn't know that that was the sign of these transitioning people. Okay. Um, and so, I've talked about nouns here because that's what we need in physics. You need nouns. What are nouns? Nouns are objects. Only objects can be nouns in physics. You cannot use the word motion, for example, the word orbit as a noun in physics. Those are verbs. Okay, so we talk about nouns, but what I've left behind are the pronouns. And this is the age of pronouns. So I want to make sure that we understand that here we have object, right? And those are the things, but as you can see, I've never touched upon pronouns. Okay, so what I did, I said, I have to come up to speed with what all these people are doing out there. A lot of companies, you go to universities and so on, and they're all putting their department of diversity and inclusion and diversity, and everybody's put it's a fad today. It's just all over the place. There's not a company, I think, that doesn't have that. Okay, so I decided to do the same thing here. Okay, so I'm going to put my department of inclusion and diversity. Okay, and there you have our 800 number. You can call it any time if you have any help, need any help. Okay, and so as part of the deal, I'm going to include my own pronouns. I think I have a right to create my own pronouns, so I created the he, she, and the him, her. and a she, he, and a her, him. Okay, I think I'm entitled to create any pronouns that I want. Okay, I don't see why not. In fact, I took it a step further. Okay, so if you're over here and you want to use pronouns in my site, you better learn all these pronouns. You know, we're going to include the theys and the its in there so that we're covered completely, so that nobody gets offended. Okay, we want to make sure that inclusion and diversity is alive and well. Okay, and I also, just in case, created my own beer. Okay, we're going to give it out to people for free so that they come and visit us. I think that's a good way of creating traffic. Right? So, just all these things that we're going to be implementing here. Okay, and Fowler said, in fact, several people had something to say about that subject. And here one fellow says, well, I don't think it is a loss of genetic diversity, because that's what I'm saying that causes the primary cause of this phenomenon is, right? Exactly, I think it can influence it. I think it's just rainbow propaganda, really. This is why this waves have mainly has affected the U.S. Another fellow says, you don't think that increasing levels of atrazine, BPA, and other testosterone suppressing estrogen producing chemicals have anything to do with it? And yet another one says something parallel to that, says autism is primarily from shots that have neurotoxic aluminum and other ingredients. Um, what can I tell these fellows? I think they're all mistaken. They're into politics, and they should do perhaps a little bit more of research. Okay, here is Calhoun's experiment, which I've shown in the past. He put 4 pairs of mice in an enclosure. He fed them all the food they wanted, all the water they wanted. They were isolated from disease. They had all the nesting material. They had no predators, etc., etc. And what happened was that eventually they became autistic and homosexual. Not all of them, but many of them. Okay, so John Calhoun, in his utopian mouse experiment, you can look it up, eventually was one of the first person to produce homosexuality in a lab, in a controlled environment. And he did it with rats, he did it with mice. He always had the same results. He did, I think, 25 at least experiments, maybe more, from 1948 to 1975. So he worked almost all his adult life on this type of project. Worked for the U.S. Army, or he was given a plot of land to do this by the U.S. Army, something like that. The Secret of Nim, you've heard that about the mice who escaped from the lab. That comes from his experiments, by the way. It's a cartoon out there. Anyways, the point is that he produced homosexuality in the lab. Okay? And these animals did not get shots, and they did not get any chemicals that would raise their estrogen, lower their testosterone, any of that stuff. Okay? And here's another example, okay? And this is out there in the wild. Some people don't like it, but you got to face reality, okay? And here's lions, mountain lions, and sheep mounting sheep, okay? Males with males, okay? And so the question is, did these animals receive any shots, or were they influenced by the politicians in their pride or anything like that? So you got to keep these things in mind. If in the animal world this is happening, then something else is going on. And what I'm saying is that what is going on, especially in the case of the lions, right? In the case of the lions, you have these animals. There were like 150,000 of them maybe 50 years ago. Now there's only 25,000 out there, I heard the other day. There's only 5,000 tigers. There's only, even fewer cheetahs, So all these animals have a very small pool to begin with. And then they all come from the same great granddaddies, forefathers. So they have very little genetic diversity. In fact, the cheetah, I think, is the animal, the cat, that has the least amount of genetic diversity in its species. And so what's going to come out of that? This is not an issue of giving it shots or educating them wrong. It's an issue that their starting material is pretty bad, okay? And people say, well, they have protection, they have little protection against diseases. I don't think that's going to kill them. What's going to kill them eventually is that you cannot have brother marrying sister when both of them have the same genetic code. That's incest is not favored by Mother Nature, and I think that's where humans are today. We are all incesting. Okay? Whoever you marry today, if you check their genetic code, I don't care if they're black or yellow or white or brown, we're all in the same boat. There's very little genetic diversity throughout the human race. And the example that you'll look up, you can look this up. They ran a test with chimps, and a troop of maybe 100 chimps out there in Africa have more genetic diversity within the troop than all of the entire human race. 8 billion of us. That's got to make you think. Why is that the case? In fact, no geneticist can answer that question. They are puzzled by it because they say with 8 billion people, we should have more genetic diversity. We create mutations every day, right? And so they forget, the bottlenecks. That wipes out half the population, and whatever mutations that we created are worthless. And so we are now, for the most part, we haven't had too many bottlenecks, maybe the world wars, some disease here and there, Spanish flu here and there, right? But in general, we've been progressing population-wise, but we come all from the same grandparents. Why do we have the same genetic code today? Why is there no genetic diversity? Because our great grandfathers, whether they were in Japan, in Africa, or in the Americas or in Europe, they went through the same sifting process imposed by diseases. Once you pass all these diseases, all those who died, they had no protection. Those who passed, they had protection, and they gave that protection to us. So we are as perfect as human beings as we'll ever get. Okay? Nothing can kill us as far as disease now because we are all the same. That's the story in a nutshell. Okay, anyways, here's again the 0D. I'm going to get into that here in a second. Give me a second here. Okay, so here we have the 0D, and that's not much to talk about. What are we saying when we say 0D? What is the 0D? Well, according to the Universal Movie, which is what you see there, Universal Movie has in a single frame only the static objects and concepts, and you need at least 2 frames of the movie to illustrate any dynamic concept. Okay, so all the ones on the bottom are dynamic concepts. You can see that they take up at least 2 frames. The one on the top take up only 1 frame. Where should we put the 0D? I mean, is this an object? Is this a thing? 0D. And, when we define the word object, we define it as, that which has shape. And so what is the shape of 0D? Is there such a monster? Okay, so that's the issue today. And so here's what the 0D looks like, okay? Get your eyes ready. Blink. That's the 0D, okay? Nothing. Okay, so this is what we're going to talk about today. Nothing, okay? I could have painted it black also, by the way, or any color for that matter. There's nothing there. That's the 0D. 0D means that it has no length, width, or height, no size, no nothing. That seems to be the definition of space. Okay, so here's the rundown. This is the mathematicians, and they harp a lot on the word 0, or on the number 0 as they call it. If there is such a number, there's a symbol, there's a numeral, but the question is, can you count to 0? We can count to 1, to 2, to 3, no problem there. We can't count the negative numbers to -1 to -2, right? Okay, that's an operation. That's not a counting. Counting, you can only count integers. And the question is whether 0 qualifies as an integer. Is there a difference between 0 apples, 0 rocks, and 0 trees, and 0 houses, 0 dogs? 0, 0, 0. There's nothing there. So, we start off on the wrong foot with this 0D already. So here it is. These are the mathematicians, the notions they have where they introduce zero and zero dimensions. Okay, you have zero to begin with. You know, the number zero. Is that a number? The answer is no. You can't count to zero. Okay, you know, can't count to 0 apples. We have the coordinate system, what they call the coordinate system, and it looks like that thing on the right over there, all those numbers. Okay, what's the problem there? Well, they put 0, 0. But see, the coordinates are used to locate something. And if you're at 0, 0, what is your location? 0 location? I have 0 location. Yeah, that's great. Okay, and so no, they're not talking about 0 coordinates, or coordinates where the number 0 is in there. They're not talking about length, width, or height. They're talking about number lines. Okay, so whenever they use a 0, it's hopefully followed by a whole bunch of integers, you know, like 1, 2, 3, 4, 5. And they're not talking about, you know, coordinates or dimensions or vectors. They're talking about number lines. That's why you know, all these people see no difference between um, you know, the time dimension, as they call it, and the space dimensions, because they're not talking about dimensions. They're talking about number lines. Okay, so 0 time, you know, how long is that? How about 0 apples? How many objects is that? Is there a difference between 0 apples and 0 dogs? Sounds like it's the same, right? So qualitatively, there's no difference. 0 length, how big is that? 0 distance seems like the object itself. You know, so the question is, can you put 0 time, 0 dimension, 0 length? Does that make any sense? Okay, so what do they mean by 0 dimensions? And one of the starting points we've always had is the point. Euclid told us something about the point. He says, definition 1, a point is that which has no part, meaning no dimensions, 0 dimensions, or 0 size. Exactly what he meant by that, nobody's exactly sure about it, but he meant 0. He says there's nothing there. A point is what? If it's not a thing. And if it's not a thing, if it's not a figure, if it's not a geometry, does it belong in geometry? Okay, so that's the question we have to answer. Does the point belong to geometry at all? If a point is location, it's a representation, a pictorial representation of location. Well, first of all, you can't represent a concept with an object. You can't represent love with a heart. And likewise, you should not represent location, a concept, with a dot. You should not confuse them, at least. Okay, either the dot is the point or the location is the famous point. And so, which one is it? Is the point both? Well, when it's both, you're trying to cover both, all bases. That's what you did. Okay, you're trying to merge a concept with an object, and that's why the point fails, and that's why they can't define it to this day. But a line is breadthless length, says, okay, so it's got no thickness, okay. The ends of a line are points, so we have nothing to nothingness at the ends of a line, okay. And a straight line is a line. I like that. A line is a line. Line is a line, a line, a line, which lies evenly with the points on itself. In other words, the line is made of 0-dimensional points. For some reason, they call it a 1 dimension. Okay, but we're not into the 1 dimension, we're into 0 dimension. That's what both of them look like. The point looks like exactly like a line, okay, because you cannot see 0 dimensions, you cannot see 1 dimension. You need at least 2 dimensions to see something, to imagine something, let alone see it. You cannot visualize this, a 0D or the 1D. Okay, so yeah, Euclid failed us as far as defining the point, and everybody just used whatever definition he had. Okay, so he continued. He used the point as the center of a circle. So he defined it as a location. He defined it as a concept. Okay, here it is. Says a circle is a plane figure contained by one line, such that all straight lines falling upon it from one point among those lying within the figure equal one another. And he was talking about some kind of wheel there, it's got all the spokes. Okay, that's what he was referring to. And he says the point is called the center of the circle. So what is a point? Point is the center. It's the location. It's not a thing. It's not a standalone thing. Okay, the point is the center, and center is the 0D, because what we're talking about is a concept. We're talking about location. Okay, so they're equated. Okay, 0D, location, center, it's all the same. Uh, it's important to know that the circle has changed over time. Okay, here's the definition that Euclid had. He says he looked at it as a bunch of spokes, and that's not what the circle is today. According to the mathematicians today, a circle is a shape consisting of all points in a plane that are at a given distance from a given point, the center. In other words, they got rid of the lines, the spokes, okay, and they just left the little dots, and they say there's a distance, not a line like Euclid said, but a distance, okay. So the line is the distance, or they're different, one or the other. But you can see that Euclid's circle looks a little different than Hawking's there, okay. Anyways, yeah, the point is the center of the circle, and it's 0D, okay. It has no shape, no size. It's absolutely nothing exactly like the 0D. Okay, it's the center. Okay, just in case, it's important to put this in here, okay? Euclid defined a figure, right? For the purposes of geometry, what is a figure? Of course, we need to know what a figure is, because geometry can't do without the figure. Okay, so he said, figure is that which is contained by any boundary or boundaries. We have a problem because the point is 0D. And so it has no boundary because it has no size, no shape. So the point, in fact, he did not define it as a figure. He did not define the line as a figure. He started defining figures starting with planes. Okay, he realized that much, apparently, that what came before, the lines and the points, he could not officially put them under figures. Okay, so he skipped that step, but then he uses the point to make every one of his figures. He uses the point to make the lines, he uses the point to make the planes, and he uses them to make the solids. What is he talking about? He's talking about location. He's not talking about point, meaning dot, meaning a thing. Okay? He's talking about a concept, location. But he's got a different, another contradiction. Here it is, okay? He says the following, he says, a boundary is that which is an extremity of anything. So a figure is that which is bound by, by boundary, and a boundary is what contains a figure. Great, we learned a lot. We have this circular set of definitions between, number 13 and 14. Okay, so yeah, we have a problem with Euclid's definition, and so it's something for you to think that we started off on the wrong foot with geometry, which was the first religion, science they call it, okay? It was an attempt to merge math with physics, and that's impossible. You cannot merge those two. Math, first of all, is a language. Physics is a discipline that explains how this universe works, hopefully, right? And so one has nothing to do with another. It's like saying that I'm going to explain using Chinese. Well, yeah, you can use Chinese or Greek, whichever you understand better. It doesn't matter. You can use any language you want. But the explanation has nothing to do with the language, okay? In the sense that the language and the explanation do not necessarily have to merge. You can use any language to explain, okay? And so that's where we started off on the wrong foot. These people try to merge math with physics. Those two cannot be merged. Math is a descriptive language, and physics is an explanatory discipline. Okay, so physics is part of science, math is not. We don't use math in science because science is about explaining, and math does not explain. That's how simple it is. Okay, you just have to define these terms to find out where to put each one properly. Okay, so they use this term known as the singularity. Scary thing, the singularity. What is that? I mean, is this a standalone object that I can bring to the conference, or that I can maybe make an image of so that I can show the congregation out there and say, look, this is the singularity. No, I can't, because singularity is a mathematical concept. It's not a thing. It's not a physical object. It doesn't have shape, doesn't have size. Singularity is what? 0D, 0 dimensions, okay? 0 dimensional, okay? Okay, so here we have one example of that, which is the Big Bang, okay? And this is what it looks like, okay? Explodes, okay? And it's allegedly what created all the matter that we have in the universe today, okay? So we started out with this little explosion, this little dot that explodes. And that little dot, that's supposedly the singularity. Okay, so you know, if we start out with a singularity, you would think, well, okay, there's something there, but they say that the singularity is 0D. It has no shape, it has no size. So we started out with nothing, ended up with something. They still haven't explained what the mechanism is for that event, that phenomenon to take place. How do you explain it? They're saying that something came out of nothing, so because they start with a singularity. And okay, I'll concede the singularity. What is it? Is it a something or is it a nothing? And they define it as 0D, so we have a nothing. That's the definition of nothing, 0D. Okay, here we have a different version of that same Big Bang. Okay, it looks sideways. It's going to explode. Okay, and so we start out with this little dot that explodes and creates this sideways looking cup. Okay, the problem is, what's the black stuff? I thought that was nothing. I thought that was space, but it turns out that space is inside this glass. Okay, that black stuff inside the glass, together with the stars and everything else, time, whatever you want to put in there, that's our universe. So what's the black stuff that gives shape to this glass? So that's the issue. The issue is, if the black stuff is 0D, if that's the nothingness, right? What is the stuff inside the black stuff inside the glass, and vice versa? If the space is inside the glass, what gives shape to the glass? Okay, so the contour has to be accounted for. Okay, here we have our universal movie. Okay, so what's the issue with this? The issue is that, you know, suddenly you have something out of nothing. That's what it is. You start out the first frame of the film, hopefully with nothing, and suddenly you have something. Turns out the something is a nothing as well. That little yellow dot that you see there is really a singularity. Singularity looks exactly like the one in frame one. And so the question is that the 0D there? Okay, so that's the question. And of course, what traditional religions do is they say, well, God created the singularity. Okay, so God moved his magic wand and he created singularity, put it in the universe, and from there everything sprang out. And the mathematicians say, well, that's not really true. That's not our theory. We don't know what happened before the singularity. We don't know how the singularity came about. All we know for sure, proven, you know, it's a fact. They say that if you take everything back one day at a time, all the way to 13 billion years or 14 billion years ago, you end up with a singularity. And so the question is, where did the singularity come from? The religious folks say God made it, and it turns out the famous singularity is absolutely nothing and looks like the one in frame one, like nothing. So again, we end up with a bunch of nothings. I told you I was going to talk to you about nothing today, so I don't know why you're listening. Okay, they also use the singularity for the black hole. At the center of a black hole, in fact, the important part really is that singularity. What is the singularity? Well, you got to go slowly. You have a star, big star. Just think of it as a gigantic star, many times bigger than the sun. Okay, this star collapses, gradually collapses on itself, gravitationally collapses. Right, it's all pulled from the edges inwards. So much so, it's got so much matter, so much mass, so much compression going on that it turns into a singularity. meaning it turns into something that has something. That's a big word there. Something that has no length, width, or height. It has no shape, no size. That's what a singularity is. So at the center of a black hole, you have a singularity. It's a mathematical concept that has to do with mass, runaway mass, actually. And the elephant's gone, but his weight remains behind. They're going to be doing stuff with the elephant's weight. But all the matter of the elephant has been crushed out of existence. There are no more atoms. Okay, so let's understand what a black hole is. They usually try to define it in different ways with escape velocity. No, that's not what a black hole is. Black hole is a star that collapsed completely to a point, meaning 0D, 0 size, 0 shape, nothing. That's what it is. But the mass is infinite or whatever. Okay? Because they don't like the word infinite when they're talking about the mass of a black hole, because if it's infinite, all black holes should be infinite in mass. And they don't like that. They have different sizes for different black holes. Okay, so this is what the black hole looks like. You've seen that. They've proven it. And so people look at that and say, oh, okay, I know what a black hole is. No, you don't. What you're staring at is not a black hole. What you're staring at, okay, let's understand what you're staring at. You're staring at, according to them, not me, okay, this is according to them, matter falling into a black hole. Supposedly there's a singularity, a nothingness in the center of that whole circular region, and the bright stuff is simply the light given off when it passes the event horizon. That's what they claim that that's what you're staring at. So this is not a picture of a black hole, because you cannot take a picture of a black hole because it's a singularity that has no size. It's 0 dimensional. That's why you can't take a picture of a black hole. It's black anyways. It's dark anyways. So they take a picture of this and people say, okay, I see what it is. That's a black hole. Yeah, it looks like a black hole. No. What you're staring at is matter rushing into a black hole. It's like taking a picture of water going down a drain. And you take a picture of water, but it turns out the drain is 0 dimensional. You can't see once the water is gone, you look and you say, well, where did it go? I don't see the hole. Okay, there is no hole because it's 0D. Okay, so let's understand that. Water going down a drain, that is 0D. Where did it go? And that's the issue. That's what you're staring at there. And that's what you got to explain. Where did the matter go if there's nothing there? If there's no hole. The famous hole is 0D. Okay, here you have what people think a black hole looks like. Should be the other way around. I put it white so that you would just understand the concept, okay? Not that it's a white hole or that black holes look white. No, it's that I put a dot there to show you what they have in the back of their minds of how they visualize a black hole. They visualize it as something infinitesimally small. Infinitesimally small is not 0D. It's not 0 dimensions, okay? Infinitesimally small just means small, okay? There's something still there. There's something that's got shape that if we had the proper microscope, God's microscope, would look something like that. That would be infinitesimally small. In fact, infinitesimally small means it's getting smaller and smaller and smaller forever. It never reaches 0 size. It always gets smaller. That's what infinitesimally small is. So the mathematicians like to use that term because, again, they cover 2 bases. It means something and nothing at the same time. It means that it's 0D, 0 dimensional, and at the same time it has shape because it's approaching 0 dimensionality. Okay, we got that? Okay, but this is exactly what a black hole looks like if we follow their rules. Just like that. Okay? That's what a black hole looks like. Nothing. Absolutely nothing, because they claim it's 0 dimensional, no size, no shape, etc., etc. Okay, so you say, well, Bill, you invented all this. That's not true. None of that's true. A black hole is not 0 dimensional. Okay, so at this point I need to introduce evidence, authority, okay? And I'm going to step aside. I'm going to let them talk, okay, so that you don't accuse me falsely. Okay, here it is. Okay, here's Stephen Hawking, and he says Chandrasekhar calculated. Chandrasekhar was a Nobel Prize winner, as you can see at the bottom there. Calculated that a cold star of more than almost 1.5 times the mass of the sun would not be able to support itself against its own gravity. Would it collapse to infinite density? Infinite density means no volume. Okay, it means 0d, 0 size, no shape. In fact, there it is. Eddington was shocked by that implication, and he refused to believe Chandrasekhar's result. Eddington thought it was simply not possible that a star could collapse to a point. Point 0d, Euclid's point, no size. Einstein himself wrote a paper in which he claimed that stars would not shrink to what? 0 size. That's what these people are talking about. And they gave the Nobel Prize to Chandrasekhar for proving that a black hole is 0 size, okay? And then we have this other gentleman. He's from a university, and he says, on solving the equation with a particular value of central density, you will get a model of a star with mass m and radius r. Plot r as a function of m and show that r falls to 0. Falls to 0. The radius falls to 0 when m is equal to the Chandrasekhar mass. Okay? So what are we talking about? Radius of 0. There's nothing there. 0 dimensional, 0 size, 0 shape. If you can do all these, then you have repeated the calculation for which Chandrasekhar won the Nobel Prize. So, what did the mathematicians prove and give Nobel Prizes out for? For proving that a star collapses to 0 size and all that remains behind is its mass. Infinite mass, or because it's got infinite density, right? Because it's got 0 volume. That's why it's infinite mass. Okay, so this is a mathematical calculation. Okay, and again, let's introduce more evidence because people say, well, that's just Stephen Hawking. What did he know? Okay, let's go with another one. It says the black hole's radius is 0. One person. Another fellow says the point of 0 volume and infinite density. Okay, creating what is known as a singularity. What is a singularity? 0 volume, infinite density. That's what a singularity is. 0d. Okay? We're talking about the 0 dimension. We're at the 0 dimension. But you might say, well, that's just 2. Okay, let's find out some more here. 0 size up to a true mathematical point. Another person says, collapses totally, talking about a star, right? To a singularity, which is what? A point which has 0 radius. Okay? It is impossible to see a singularity. No kid. Got to have good eyesight to see nothing. Okay, so just in case other people rub it in from a different point of view, but say the same thing in different words, they say that a black hole crushes all matter out of existence. There you have 3 references. You can look them up. Okay, all these people believe that the star, okay, known as a black hole, gigantic star that is collapsing under its own weight, under its own gravity, collapses to 0 size, crushing all matter out of existence in the process, so that eventually they end up with a singularity, which is 0 dimension, 0 size, no shape. Okay, so let's understand what we're talking about when we talk about 0 dimensionality, Big Bang, and black holes, especially those 3, right? Okay, so this is what it looks like. Okay, you see the star. Okay, think of this as a star, a gigantic star, and over time it collapses to nothing. Okay, so it doesn't end up with a point. It crushes all matter out of existence and ends up with nothing, with 0d. And until you get that through your skulls, you're going to have a trouble understanding what a black hole is and what kind of BS they're trying to sell you, okay, the mathematicians. To them it makes sense because they just deal with numbers. To a physicist, it makes no sense whatsoever. So if you're a physicist, if you're a rational individual, you're going to reject this notion of a black hole, okay? Okay, so what's the problem with what they're saying? Well, they have all this matter, right? They're going to crush it out of existence, okay? Turn it into 0 size infinite density, no shape, okay? And so here it is. We have a little circular argument there because a black hole is made out of mass, right? But mass is the quantity of matter. That's how it's defined. So we say, okay, a star has all this matter, the quantity of matter, that's what we call the mass. We measure it in kilograms, but kilograms is a measure of how much matter the star has. Okay, a gigantic star, millions of times bigger than the sun. Great, no problem. Okay, so now this matter, because of its own weight, because of its own gravitational attraction towards its center, it's collapsing in on itself. So it's collapsing, compressing everything in there until all matter disappears. All matter disappears. Okay? So it crushes all matter out of existence. We have no matter, but they say the mass remains behind. They crushed the elephant out of existence. Not a single atom remains, but the weight of the elephant, is still there and is causing all kinds of problems to stars or whatever's out there. So we have a contradiction because if mass is the quantity of matter, that's how they define it in this context, right? And if that's what mass is, the quantity of matter, we crushed all matter out of existence. How do we still have mass? That's the issue. So they have a contradiction. They have a circular argument. Okay, these are the things you got to keep in mind. Okay, so it's funny because here we have NASA, and what does NASA do? Well, NASA talks about the sizes of black holes. Okay, and I don't know how you can imagine this because if a black hole is a singularity has no size. What sense does it make to talk about sizes of black holes? And this is a video that you can look up at NASA. It came out recently. Here it is. I'll show it to you. Yeah, I'll show it to you in fast motion because they show it in slower motion, but here it is. And they're talking about sizes here, okay? You can see that they're just zooming out. And they're eventually going to show the biggest black hole in the universe, which is bigger than all this combined. That's what you're staring at. Okay, so ton 618 is bigger than all that stuff that you just saw. That's what they're saying. That's how big this black hole is. So what are they talking about? Let me show it one more time so that if you missed any part of it, you can see it again. What are we talking about? We're saying that we have this black hole which is bigger than several galaxies put together. That's essentially what they're saying. And that's this ton 618. Here it goes again. You can see our little sun there compared to the solar system first. And then you have other galaxies nearby. And this thing, this black hole, they say is bigger than all of them put together. Milky Way, there you have, Andromeda. And with all that, this gigantic black hole is bigger than all of that. How can that possibly be if a black hole has zero size? In other words, a singularity. What are they talking about? Okay. Well, when they talk about sizes, they're not talking about bigness like shape. They're not referring to shape, they're referring to mass. So when they talk about size, they use it in terms of mass, not in terms of shape. So when you talk about size, size of an elephant, you're saying, well, this elephant is bigger than that one. What? You're talking about the shape. You don't say, well, because if you're going to talk about weight, you say, let's weigh them, and say, well, this one weighs more than that one. That's not what they're saying. Or has more mass than that one, more atoms. Yeah. But that's not what they're saying. They use the word size. They give you an idea, or they try to convey the idea that they're talking about shape. That this one has a bigger shape than these other things. That's what they're saying. Okay, and so here you have one individual, and he says the following. He clarifies to us. He says, talking about black holes in terms of size is inherently perilous, mostly because of gaps in language. We talk about things like size when they don't really apply because we don't have a better way to describe them. Absolutely a lie. We have a way of describing them, but they want to use the word size in the wrong context on purpose to mislead you and to mislead themselves. They're not talking about size. They should simply talk about more mass or weight or whatever they want to talk about in mathematical terms. They're not talking about size. They are deliberately misleading you and misleading themselves when they use the word size. The true size of a black hole, even the largest, is impossibly small. That's kind of their whole deal. Even the most massive black holes are, in fact, quite small, just singularities in space-time which harbor so much mass they'll happily swallow anything and everything that comes into grabbing distance. When we talk about the size of a black hole, what we're really talking about is the diameter of its what? Event horizon. And those can reach truly incredible sizes. Okay, so they're talking about the region of influence of the singularity. Okay, singularity is zero size. If it's zero size and has no matter, then it has no influence over anything. But they created this campfire notion. Okay, it looks like this. Okay, when you're in a campfire, okay, you're sitting around it, you have this fire going on. But the fire isn't just constrained to where the wood is. The campfire really extends, the heat extends way beyond you. So you can think of as the fire as being the zero-dimensional singularity, if you can turn that into a 0D. But the important part here, when they're talking about size, they're talking about the region of influence, so to speak, the heat of the campfire. Okay, so the region of influence and how far it extends is what they call the event horizon, and that's when you have this escape velocity issue. Okay, so they call the black hole the whole thing, not only the singularity at the center, but also the region of influence, and that is what is so misleading about what the mathematicians do, because they're not really talking about physics. They're talking about a region of influence of something which has no size, no matter. How can that affect anything? It's again the case of the water running down a zero-dimensional drain. Once the water's gone, you say, well, where's the hole? Well, there is no hole because it's zero size. And zero size means you still have the sink and no drain. You have forgot to put the drain in there, but the water rushed through there. That's what they're trying to sell to you. Okay? And they use words like infinitesimally small instead of saying the correct word. Zero size, zero dimensions. Okay? And yeah, so you'll see infinitesimally small. They crush it out of existence. They use those terms. And yeah, what they're talking about really is the vacuum, nothing. Okay, we're talking about nothingness throughout this whole thing. And so, what is the 0D? Well, 0D is absolutely nothing. It's the point, which is simply a location. Location is not a thing, so you can't talk about dimensions in terms of location. Okay, location has no dimensions. Okay, so I don't know why they call it the zero dimensions, the point, or zero dimension. It's also a synonym of singularity. What is a singularity? It's what is the center of the black hole, and it's what gave birth to the universe. Maybe in the Big Crunch we end up in another singularity. Okay, so they use all these terms, and what are they talking about? They are talking about nothing. That's what the 0D is. Zero length, that's absolutely nothing. What's zero time? Absolutely nothing. What is zero apples, zero trees, zero rocks? That's absolutely nothing, and they're all equal. So they like the zeros, okay? But zero means absolutely nothing. You can't count to zero. So 0D, to summarize, is nothing. And so this whole time I've been talking about nothing. Okay, let's move on to our questions, comments that people made. One fellow says, if all atoms in the universe are connected by ropes and there are 10 to the 80 atoms in the universe, that would imply each atom would have 10 to the 80 ropes attached to it. Okay, good. That's math, okay? That's a lot of ropes per atom, okay? Yeah, okay, so it's a lot, many, much, okay? Also, some ropes would have to stretch from one edge of the universe to the opposite edge. Okay, am I missing something? No, I think you said it quite well. I think you described what we're talking about. So you regurgitated uh, the proposal, the hypothesis, the rope hypothesis. I'm not sure if there's any question other than that, but yeah, you're not missing anything. The ropes converge upon our atom, and there's gazillions of ropes. I wouldn't say it's 10 to the 80. I would say 10 to the thousands to the millions. I think it's uncountable the number of ropes converging upon an atom. And you say, how can that possibly be? And again, you're thinking of touch, see and touch, but primarily touch, and this is what trips up everybody. Everybody's thinking of touch. And the ropes have no ability to touch. You have no ability to touch a rope. A rope has no ability to touch another rope. So they can superimpose no matter where they are in the universe. You can put gazillions of ropes on the same axis. So no question, I guess. He just said, am I missing something? No, you're not. Okay, you get it right down. Okay, another fellow says, or asks, or comments, he said, I'd say shadows and reflections are 2D, but they don't exist independently. I guess that's the caveat for 2D, second dimension, right? Another fellow answers, yes, shadows and reflections are 2D, having no depth, okay? Depth is not a dimension, but okay, we'll allow them to use the word depth there. Depth is a vector, but he probably wouldn't know the difference. Shadows and reflections aren't just conceptual, residing in the mind or minds of humans as abstract ideas. 2D geometry casts 3D, casts from 3D. Yeah, shadow is not a thing. Shadow is light. Okay, shadow is simply light. And so we have to distinguish between a thing and what the thing does. Okay. Here's one way of putting it. Rope is a thing. It's an object, a thing. Okay. Here's a rope. This is what a rope looks like for those of you who never saw one. Go to a hardware store, ask for a 2-strand rope, and they'll give you something similar to this, hopefully. Okay. So you can take it home and you'll find out that it's an object. It's a thing. And that's what we're saying that this object looks like. Okay, that's the general shape of this thing. Okay, a pair of twined threads. Very simple, very thin, elongated threads. That's what they are. That's what we're proposing that light is. That's the mediator of light. What does that do? It torques. There's torsion. Okay, it torques in place. So you don't need to send little bullets like in quantum mechanics from one atom to another. It twirls in place, and therefore by twirling in place you get the signal instantaneously almost at the speed of light, 300,000 kilometers per second, at each end, at each atom that is connected to that rope. Okay, so we have to distinguish the object, which is the rope, from what it does, which is torsion. Okay, torquing. Okay, so just so we understand where we're at, another fellow asks or comments, he says, space has shape. If you have a cube in the almost perfect vacuum of outer space that's composed of 27 small cubes, 3 columns, 3 rows, 3 cells, okay, there I try to picture it, okay. Remove the center cube, we'll assume that black one there is the hole that it left behind, okay. There's a space that has length, width, and height in the center. That's space. Okay, we don't know if that space has, all we know is that the cube has the space. You haven't shown that it's got length, width, and height, because if you remove all the other cubes, you won't have any length, width, or height. Ultimately, all is energy, space, and it's certainly not conceptual, residing in the mind or minds of humans as abstract ideas. Exist, physical presence. Yeah, space equals no physical presence. Okay, that's not what space is, but that's a description. You can't define something like space, a concept, in the negative. No, you have to say space is that which doesn't have shape, meaning I cannot define it as the absence of something. Okay, we cannot have one without the other. What's in between physical presences has shape. Well, the issue is, can you have a standalone cube of space? Right now you've shown is that the glass has water in it, not that that the part above the water is an object. The water is an object that's inside it, not the empty space above it. And what this fellow is trying to tell you is that the space above the glass of water is a standalone object. And the answer is no. If you take the water and the glass out, you won't have that space there. Okay, so there is no such thing as space. And in this case here, you have these 27 cubes. If we remove the cubes, will we still have a cube of space with length, width, and height? The answer is no. Okay, so again, the question is the glass half empty or half full, more or less? That's the issue. Okay, and another fellow says, well, he sends me to a video, okay, and says that talking about waves. And the funny part is, as soon as you get like less than a minute into the video, he says, the fellow who made the video says, I don't have a clue what an electron looks like, or what mass is, or charge, or spin really are. Well, that's a bad way to start a presentation. I mean, if you don't know anything, what can you teach? And yeah, it's these people who have hundreds of thousands of visitors and subscribers. Very few people go through the narrow path of knowledge. Many people go through the wide open spaces of ignorance. That's what it amounts to. Anyways, with that, we'll see you next week.